Hello everyone, myself Sachin Rathod, working as assistant professor in Department of Mechanical Engineering from Walchand Institute of Technology, Solapur College. So today we are dealing with a design of the clutch part 2. In the last session we had seen the design part of the single plate clutch, under which we had seen the design part of the by considering the uniform pressure theory. Now for today's lecture we will see the design part related to the uniform wear theory. So the learning outcome of this session is learner will able to calculate the torque transmitting capacity of the single plate clutch. So this is a second theory. In the last session we are seeing the uniform pressure theory. This is a second, that is uniform wear theory. So we had consider for the uniform wear theory, the product of intensity of the pressures and the radius is constant. The maximum pressure intensity at the inner diameter d by 2 is denoted by Pa, and it is also permissible intensity of the pressures. So if I am going to consider the area under which the friction lining is there, just I will draw the figure, excuse me for this. So already we had learned about this in the last slide. This circular, that is here the ID and OD of the plate, clutch plate, in which the friction lining is going to occur for this surface. So at the inner, that is the ID of the clutch plate, in which we are getting the maximum pressure. So that maximum pressures we are considered as a PA. So since PR, that is the product of the pressure, intensity of the pressure and the radius is constant, we are getting that PR is equal to PA into D by 2, right. So this is nothing but, we are getting that this is a small d, so we are getting the radius is nothing but the D by 2, and the intensity of the pressure is maximum at the innermost, that's why we had considered the PA. Then the similar theory is there as we had observed for the uniform pressure theory, that is a elemental axial force, the total amount of the elemental axial force is 2 pi into P into R into dr. Then by the elemental axial force you can easily calculate the total amount of the force just by integrating from this surface to this surface, that is nothing but integrating from d by 2 to capital D by 2. We can easily find out the value of the total amount of the axial force P, that is a P is equal to 2 pi integration of small d by 2 to capital D by 2 into P into R into dr. After the integrating we are getting that this is the constant terms, that is the product, already we have discussed about this. The P into R is equal to constant for the uniform wear theory, so that the constant terms will get outside of the integration. So we are getting 2 pi into PA into D by 2, that is the P is nothing but the PA, maximum intensity of the pressure at the innermost radius that we had observed. Then the R is nothing but the D by 2 integration of small d by 2 to capital D by 2 into dr. So we are knowing that the integrations of dr is equal to R. So by integrating lower limit is d by 2 and the upper limit is d by 2, we are getting the equation of the total amount of the axial force P is equal to pi into PA into D by 2 in bracket capital D minus small d. For that we had given us equation number 4. Then the elemental frictional torque. So the torque is nothing but elemental frictional force into the radius. So already we had learned this in the uniform pressure theory, so that's why I have written directly. If any doubt is there, you can see the previous video. That is a 2 pi into mu into P R square dr, that is the elemental frictional torques. Again we need to calculate the total amount of the frictional torque by considering the uniform wear theory. So that's why just I will remove this, just excuse me for this. Yes, that is the total amount of the torque. For getting the total amount of the torque, just you have to integrate this equation from lower limit, that is the d by 2 to the upper limit d by 2, you will get the total amount of the torque acting on the clutch plate. So after integrating this we are getting these equations. So this equation is nothing but the total amount of the torque. Now for finding, that is for getting the relation between the total amount of the torque and the applied force, divide the equation number 5 with the equation number 4. After dividing the equations, we are getting the total amount of the torque mt is equal to mu into total amount of the axial force divided by 4 into capital D plus small d. So like this way we are getting the total amount of the torque transmitted by the single plate clutch under the uniform wear theory. Okay, so this is about the total amount of the torque. The next we will see one numerical based on the uniform pressure theory for the single plate clutch. Just see the sentence or the statement for this numerical. A plate clutch consists of a one pair of contacting surface. The inner and the outer diameter of the friction discs are 100 and 200 mm respectively. The coefficient of friction is 0.2 and the permissible intensity of the pressure is 1 Newton per mm square. Assuming the uniform pressure theory, calculate the power transmitting capacity of the clutch at 750 rpm. So they had given us, you have to assume the uniform pressure theory. So definitely the clutch plate is new one. So for that purpose only we are using the uniform pressure theory. So as per the statement, the given data is capital D is 200, small d is 100, coefficient of friction is 0.2, intensity of the pressure is 1 and the speed is 750 rpm. Now we can calculate the operating force, that is a capital P. So we are knowing the operating force capital P is equal to pi into P, that is the intensity of the pressure by 4 in bracket capital D square minus small d square. Just put all the value, you will get the answer, that is a operating force is equal to 23,561.95 Newton. Then in the step 2, that you can calculate directly the power transmitting capacity, that is a required question. So already we are knowing the value of the mt, that is the power transmitting capacity, by considering the uniform pressure theory. The equation is mu into P by 3 in bracket d cube minus d cube divided by d square minus d square. So by referring these equations, just put down the value, you will get the total amount of power transmission, that is a 366519.22, that is the amount of the torque. So by the torques you can easily calculate the power by using the equation. Power is equal to 2 pi mt divided by 60 into 10 to the power 6. Just put the value, we are getting the total amount of the power is 28.79 kilowatt. So this much amount of the power transmitting capacity of the given data accordingly. So this is a numerical based on the single plate clutch. So next theory is about the multi-plate clutch. So as the construction is same as the single plate clutch and the multi-plate clutch, in the single plate clutch only we are using the one plate only, that is the contacting surface will be the one, and in case of the multi-plate clutch there are the several plates are there. Okay, so if you are going to observe, first, second, third, 3 plates are there, that is the contacting, and these are the friction lining is there, that all the friction lining is going to connect with the flywheel, and this disc or the plate is going to connect with the driven shaft, right. So the construction will be remain same and the working principle will remain same, but the difference between single plate and the multi-plate clutch is that if the radial space is too much high, then you can prefer the single plate clutch. If the radial space is too much, we can call it, if it is less, then you can prefer the multi-plate clutch for the required torque transmission capacity. And the one more, the difference is that the single plate clutch there we required, that is a kind of the dry clutch, because the area is too much high, so there is a heat dissipations will be there in case of the single plate clutch. In case of the multi-plate clutch, so we require to provide certain kind of the wet surface. So already we are knowing, already we have derived the equation for the uniform pressure, that is the mt is equal to, just we had introduced here the z nothing but the number of active surface. The equation remains same for the calculating the torque by considering the uniform pressure theory, and for the uniform wear theory the equation remains same, just we have to introduce here the term number of active surface, because it is not the single plate clutch, it is a multi plate clutch, multiple plate they are going to use. So see that we are introducing here the value of the Z. So where the Z is the number of the pairs of contacting surface, or it is also called as a number of active surface. It can be calculated Z is equal to Z1 plus Z2 minus 1, where the Z1 is the number of the friction plates on the driving shaft, and the Z2 is nothing but the number of the friction plates on the driven shaft. So if I am going to consider this given application, so for that application, if you want to find out the value of the Z, this Z, we can easily get the value of the Z, that is Z1 is the number of the friction plates on the driving shaft. This is the driving shaft. To the driving shaft, the first plate, second, 3 and the third plate. So there are the 3 plates are going to connect, that is the friction lining is connect to the driving shaft. And if I am going to check the driven shaft, this is the driven shaft. To the driven shaft, the disc or the plate is going to connect, that is the first, second and the third. So there we can write down Z1 is equal to 3, Z2 is equal to 3. Therefore, I am getting the total amount of the active surface Z is equal to 3 plus 3 minus 1, that is a 5, right. So like this way we can calculate the value of the Z, and the remaining theory will remain same for the single plate clutch and the multi plate clutch. Okay. So like this we had calculated the value of the Z, that is the active surface. Okay. Okay. Reference, so I have taken a references from the V.B. Bhandari book. Thank you.